Hello friends. In last video I explained that when the vehicle is moving along a horizontal curved road, in that case force of static friction provides the necessary centripetal force which act against the centrifugal force in order to keep the vehicle at position, and it will prevent the vehicle from overturning and skidding. Also, we have seen that this force of static friction has the maximum value mu s into n. This coefficient of friction mu s has different values at different road surfaces. To overcome this drawback and preventing the vehicle from overturning or skidding in the real life, the surface of road is tilted with the horizontal with some angle theta at the center of curvature. This is called banking of road. Banking of road, and the angle theta is called banking angle, and this is used to prevent the vehicle from overturning and skidding. In this video, we are going to see vehicle moving along a banked road. This is the horizontal, this is the road surface. So it is inclined at an angle of theta. The road surface is inclined with the horizontal at an angle of theta. This is called as banking of road. Initially, we are ignoring the friction. We are not eliminating, we are just ignoring the friction. The forces acting on the vehicle body are first weight of the vehicle mg, normal reaction perpendicular to the road surface is n, centrifugal force mr omega square away from the center. This normal reaction is in inclination with the vertical at an angle of theta. So we can resolve this into two components. One is horizontal, that is n sine theta, and the vertical component, that is n cos theta, right? So two components of normal reaction, horizontal component n sin theta and vertical component n cos theta, as it is inclined at an angle of theta with vertical. So this angle is theta, so this angle will become theta. Now the forces acting on vehicle are: first, weight of the vehicle, mg acting in downward. Second, the normal reaction n, it has horizontal component n sin theta, vertical component n cos theta. Now see, the vertical component of the reaction balances the weight of vehicle, and this horizontal component of reaction balances the centrifugal force of the vehicle. So we can write n cos theta is equal to mg and n sin theta is equal to mr omega square, can be written as mv square by r. So taking the ratio, what we get, n sin theta upon n cos theta is equal to mv square upon r mg. So will get cancelled, we get v square by rg. Mark this as equation 1. So using this equation, we are going to find out first shape speed, second banking angle, that is theta, and third speed limit. So we will see one by one. First we will find out the self limit. For particular road, values of r and theta are constant or fixed. So from our equation, n sin theta upon n cos theta is equal to v square upon rg. We get tan theta is equal to v square upon r. V square is equal to rg tan theta. For safe value of speed, v safe is equal to under root rg tan theta. Okay, so this is the expression for
Safe value of speed.
Second, the banking angle. Can we find out from same equation? tan theta equals to v square upon rg. So theta is equal to tan inverse of v square upon rg. So this is the expression for finding out the banking angle. Theta. Third, we'll find out the speed limit. Now for step speed, we have the value of velocity as equal to v is equal to under root rg tan theta. Now this is for single speed, but in actual vehicle may travel with speed greater than or less than. Vehicle may travel with greater speed than the safe speed or less speed than the safe speed. So for higher speed, the force of static friction helps for preventing the vehicle from overturning or skidding up to certain limit. We need to find out the upper speed limit and lower speed limit. And for this, we consider the static friction force. We consider the static friction force. For lower speed than safe speed, vehicle tend to move towards center. Static friction force will act away from the center. So it will have two components, one is horizontal and the other one is vertical. This is angle theta, the angle of banking theta. So its horizontal component is Fs cos theta and vertical component is Fs sin theta. Others are same. Weight of the vehicle acting downward to normal reaction perpendicular to the road surface, then we can resolve it into horizontal and vertical components. And cos theta and sin theta, this is the angle theta. We are going to find out for speed v1 less than under root rg tan theta. So rg tan theta is the safe speed. It is the safe speed. For safe speed, we can say that the centrifugal force must be less than n sin theta, the horizontal component of the reaction, n sin theta. That is, centrifugal force must be less than n sin theta. Then and then only our vehicle will get prevented from overturning. Because of this, the direction of Fs is away from center. This horizontal component Fs cos theta and vertical Fs sin theta. So we have some horizontal forces and some vertical forces. So balancing the forces, acting on vehicle, mg is equal to Fs sin theta plus n cos theta, and the centrifugal force mv square by r is equal to n sin theta minus Fs cos theta. So in this, we are considering the upward forces as positive forces, downward force as negative force, towards right as positive force and towards left as negative. For minimum possible speed, Fs must be maximum, that is mu s into n. So the minimum possible speed can be written as V minimum is equal to under root Rg tan theta minus mu s divided by 1 plus mu s tan theta. So by using this expression, we can find out the minimum possible speed. For mu s less than equal to tan theta, V minimum is equal to 0. So we can write this from equation. Therefore, because of this reason, the rough roads are banked with smaller banking angle. At higher speed, vehicle tends to overturn on banked curve road. So for this, the direction of static force Fs is towards center. So direction of static force is towards center. So it will have two components. One is horizontal and the other one is vertical. So horizontal component is Fs cos theta and the vertical component is Fs sin theta. The remaining forces will be self weight of the vehicle mg. The normal reaction perpendicular to the road surface. The normal reaction has two components. One is vertical, the other one is horizontal. This is the angle theta. Vertical component is n sin theta. Sorry, it is cos theta, and the horizontal component is n sin theta. This is the angle theta, that's why n cos theta and n sin theta. Balancing the forces acting on vehicle. The centrifugal force will act away from the center. Mg is equal to n cos theta minus Fs sin theta, and the centrifugal force Mr omega square or mv square by r is equal to n sin theta plus Fs cos theta. So horizontal forces Mr omega square or mv square is towards right positive, and this n sin theta and Fs cos theta are towards left side, that's why they are negative. So mv square by r is equal to n sin theta plus Fs cos theta. For maximum possible speed, Fs is equal to mu s n. Vmax can be given by expression under root rg into tan theta plus mu s divided by 1 minus mu s tan. Of this expression we can find out the maximum speed over a banked curve road.